Classical physics is all about forces. So, what is a force? At a very basic level, a force just represents a push or a pull. At a deeper level, we're going to find that forces really comprise a whole way of thinking about nature. In many ways, when Isaac Newton laid down his laws of force and motion, and there's mainly three of those that we're going to be going into in the next topics, he set the framework for how science would be done. If you wanted to formulate a hypothesis for how things should work in nature, you had to state it in terms of forces. So forces in that sense became the language of physics and really brought more broadly kind of the foundation of other branches of science that sort of have physics as their foundation. This topic, the intention is that we're going to introduce some techniques for working with forces and for how to understand real situations and be able to say things about motion using forces. So it says here that forces are represented by vectors and can be drawn as a free body diagram. And we are going to refer to the free body diagram as FBD for short. Now, maybe not every single physics class in the world does free body diagrams. There are definitely a lot of different ways you can represent forces, like you can just draw them in as arrows into a picture, into a sketch if you want. The idea behind a free body diagram, though, is going to be to have a sketch and then separate from that, draw the forces. So it's kind of abstracted from it, and it also kind of makes it clear, like, here's what I think reality looks like for this situation, and here's what I think the forces look like for that situation. The SI unit of force is named after Isaac Newton, since he kind of gave us this framework for working with forces and understanding nature based on them. So it makes sense to name the new unit for describing how big a force is after him.